All right, welcome to Academy. My name is Mr. Carlson. We're going to look at a geometry lesson today where we're looking at determining if lines are parallel to each other. This is Powered Standard Skill number 7, or excuse me, number 9, and let's get started by looking at the definition of parallel lines. All right, we know from previous courses that parallel lines are always the same distance apart and they will never intersect. But what we want to do today is we want to look at how does that affect the way those lines look when we're looking at the equations of those lines, which leads us to the idea of this parallel lines and slopes theorem. And the parallel lines and slopes theorem just says that if you have two non-vertical lines, they're parallel to each other if and only if they have the same slope. Okay? So what we're now doing is we're relating that topic from algebra of slope to the geometry topic of parallel. So what we want to be able to do now is we want to be able to look at equations in different forms and decide whether or not those lines would be parallel to each other. Alright, let's take a look at this first example problem then. It says, are these two lines parallel to each other? Well, in both cases the equations are written in the exact same form. That's a form that you learned in your algebra course, and that's what we called slope-intercept form. And that was of the form y equals mx plus b. And what we know from that form is the value of m, that whatever the coefficient is, or that number that comes in front of x, whatever that number is, that value is the slope of that line. So determining whether lines are parallel to each other if it's already in slope-intercept form becomes a very easy task, because all we have to do is look for that value of m and determine whether it's the same. So as I look at these two equations, you'll notice in both cases the number 2 is the coefficient of x. Therefore both of these lines have a slope of 2. Therefore these lines must be parallel to each other. So the answer to this question is yes, these would be parallel to each other. Alright, in the second example problem, we're really asking the same question. The problem is that these two equations are not in slope-intercept form. So our job is going to be to get them into slope-intercept form, and then once we have them there, just like before, we can test to see if that value in front of the x is, if those values are equal to each other. So let's go ahead and see if we can put these two equations in slope-intercept form. I'm going to start with this one. And the first thing that I'm going to do is I'm going to go ahead and I'm going to bring the x over to the other side here. I can do that by subtracting 3x from both sides. Now when I do that, I'm going to have negative 2y is equal to, and now I'm going to put this x term first because I want it to look like this slope-intercept form. So I'm going to write negative 3x first, and then I'm going to take the minus 12 and write that next. Okay? And the only thing left for me to do to get that in slope-intercept form, you'll notice that in slope-intercept form the y is by itself, and right now I have a negative 2 with that, so I'm going to divide by negative 2, and when I do that I'm going to do it to each term on both sides. Okay? And if I do that here, I have y. Here, part of the deal is to try and simplify that. So this is a negative 3x over negative 2. So I can deal with those numbers and bring that out front to get the m value. So negative 3 over negative 2 is just the same as 3 over 2, because those negatives will cancel out. And then I can put the x next to it because I'm still multiplying by x. And then if I have a negative 12 over negative 2, that's going to give me a positive 6. So in slope-intercept form, that equation would be the following. Now you'll notice that I'm circling that because that is the slope. Therefore I know the slope of this line is 3/2. What I would like you to do now is, can you pause the video and just see if you can put the second equation into slope-intercept form, and then we'll determine whether or not those two lines are parallel to each other. Alright, I'd like you to check your work and see if it matches mine. Here is what I have for that equation in slope-intercept form. And you'll notice that in this slope, although it looks very similar, it is different. The slope of this line is 2/3. Now, since this one's 3/2 and this one's 2/3, these slopes are not parallel to each other. Therefore, the answer to the question is no.